In our pre-lecture, we were to fill in the blank, and we have some notes about a frequency distribution table. So first off, what is a frequency distribution table? It is simply a way to organize data. The data is organized into classes, and the key thing is the classes must be the same size, and they cannot overlap. So we'll have to keep both of those details in mind as we create a frequency distribution table. It is common for a frequency distribution to have between 5 and 20 classes. Fewer than 5, more than 20 is typically not done, and really 20 is a lot of classes. So more like the 5 to 10 would be the most common. And then finally, many times the midpoint is found of the classes. And so to do that, what you do is you take the lower class limit, you add the upper class limit, and you divide by 2, and that gives you the midpoint. So let's take a look at a very small data set that we can organize by hand and how we would set up this frequency distribution table by hand. So for a very small data set, I have the first 30 values. This is from a greater data set of 253 students, but I would not want to organize 253 numbers by hand. I'd let technology do that. And so what I do is I look through my data, and I want to first identify what is my lowest and what is my highest value so that I know how big of a range of values I need to cover. So in scanning through, I think that this 5.02 is my lowest. And I think that this 9.87 down here is my highest. So organizing my data, I'm going to use the concept that's similar to a spreadsheet. And so I'm going to start out from our notes with the data to be organized into classes. So I'll have my first column header as class. And then my next column will be the tally. And the tally is just when we go through and we actually put down tally marks to see how many items fit in that class. And then we'll have the frequency. And the frequency is just where we count the tally marks. The frequency is a count of tally marks. And then we'll also find the midpoint, because you'll be asked to do that a good bit in your homework. And we'll come back to that when we talk about creating a histogram of how you might use that information and why you would do that in the first place. So when I create my classes, our notes that we took before class said that we should have between 5 and 20 classes, all the same size without any overlap. So just in looking through this data, it feels like I could go like 5 to 6, 6 to 7. Basically, my data goes from 5 to 10. So there's an issue, though. I can't quite do it that easily. So in my head, I'm thinking basically 5 hours to 6 hours of sleep would be that first class. And so then my next class would be 6 to 7 hours. But this is where I run into an issue, because the 6 creates an overlap. So if somebody slept exactly 6 hours, I don't know which class they would be in, because they would fit in both classes. And so instead of having the same number end a class and begin a class, I have to make them different. So I'm going to end this class at 6, and I'm going to start my next class at 6.01. Now, I have to use 2 decimal places here because my data has 2 decimal places. So this matches the decimals in the data. So I encounter the same thing as I go to the next category. So I would want the next class to start at 7, but I can't reuse the 7. So I'll start at 7:01 to 8, and then from 8.01 to 9, from 9.01 to 10, and our Highest value was 9.87, so we don't need to go higher than 10. So I have my classes not overlapping at the moment, but I do also have one more problem, and that is my very first class is not in the same pattern as my others. And so technically this very first class is 1/100th wider, bigger than the other classes. So I have to go back and start this at 5.01 so that it is the exact same size as every other class. So all my classes are exactly the same size. All of my classes are separated. They do not overlap in the least. So I'm going to take a moment here just to clean up my handwriting. So this first class needs to be 5.01 to 6 so that it is the same size as all the other classes. Now I'm ready to go through and make my tally marks. So this is hard to demonstrate on screen, but literally I'm putting a finger on this number 7.18 and then my pencil's over here giving a tally mark to that. So 7.18 is in the category or class from 7.01 to 8 hours of sleep. And so then I go to the next data value. So 6.93 would be between 6 and 7, so that gets a tally mark again. I'm just using one finger to track through my data, and the other hand is writing the number, writing a tally mark. So my third piece of data goes in the first category or class. 6.9 would be between 6 and 7. 6.35 is between 6 and 7. 9.04 is way up here in this last category, between 9 and 10. 7.52 is between 7 and 8. Okay, all my categories separated here in my chart. And so this is where my chart really feels a lot like a spreadsheet with all these little cells. Next is 9.01, so that's my last category. 8.54 is between 8 and 9. 6.68 is between 6 and 7. 8.09 is between 8 and 9. 8.43 is between 8 and 9. 6.89 is between 6 and 7. So that's my first group of 5, and I usually go diagonal to group them by 5 to make it easy to count my tally marks. 7.45 is between 7 and 8. 8.93 is between 8 and 9. 8.9 is between 8 and 9, so that group is another group of 5. 8.34 is between 8 and 9. 8.22 is between 8 and 9. 8.39 is between 8 and 9. 7.43 is between 7 and 8. 7.29 between 7 and 8, a group of 5. 8.57 between 8 and 9. 9.39 is between 9 and 10. 9.57 is between 9 and 10. 8 exact. So this is why we could not use 8 as both the end of one class and the start of the next, because it has to go a distinct location. So the 8 exact fits in the category from 7.01 to 8. So that's where I'll put that tally mark. 9.87 is in my final class here. That's a group of 5. 8.75 makes a group of 5. 8.57, start the next group. 7.71 is between 7 and 8. 7.43 between 7 and 8. So now I go through and I just count up my tally marks. So in this first category, I just had 1, so that is a frequency of 1. The next I had 5, then 8, then 11, and 5. Now the midpoint. So in order to find the midpoint, you want to grab a calculator. And what we have in our pre-lecture notes is that you take the lower limit plus the upper limit and divide by 2. So I'll take 5 0.01 plus 6 and divide it by 2. So order of operations comes into play. Make sure you add on the top and get 11.01 before you divide by 2. And you should have 5.505. As the midpoint. And so then you repeat for all of these. So you'll do 6.01 plus 7, and then divide that by 2. And when you do that, you'll get 6.505. And we'll do one more here. And so for this third one, we would take 7.01 plus 8, adding the upper and lower limits, dividing by 2, and we'd get 7.505. It's really easy to see the pattern here. So I'm not going to write out all my math, but this would be 8.505 and finally 9.505. And if you wanted to round, you could round somewhere. I did not round at all on these, but wrote out the full decimal. So that completes our frequency distribution table, and as we said at the beginning, it is literally an organizational tool. So you see that we have organized the information into the classes. We made certain that our classes did not overlap, and we made certain that our classes were all exactly the same size. And then we went through and tallied up how many data values fit into each and every class.